All right. Welcome back, everybody. We are here again on the Mr. Scheuch Science Stream. Hope you're all having a good day. I know I am. Another day, It's Wednesday. That's cool. It's Wednesday. We made it halfway through the week. Hump day. Hope you like my hat today. I'm not going to be wearing it very long because it's really, really hot under here. So hopefully things are better today. If you could give me a shout out here on the chat so I know what's up. Let me know if things are looking better, sounding better, things like that. All right, I got to take this thing off. You guys want a hat every day. This is the best I could do today, so I'm going to take it off for now. Whew. Man. Put this one on. Whew. Hopefully that's better. All right. What in the world, Alana? Did that surprise you? Yeah, kind of surprised me too. All right, so is it better? Are we doing better today? It looks like it. On my end, it looks like it. Don't be scared. It's really me. It's really me. All right. Can I breathe? Yeah, I could breathe. There's a little mouth hole right here. Yeah, you can breathe in there. It's a little tough, though. Hey, whose birthday is it? Alana, it's your birthday for real? Happy birthday. Happy birthday. Awesome. So cool. Birthday on a hump day. Nice. All right. All right, so I put myself at the beach today because, it's kind of another gloomy day. Yeah. I put myself in Sea Isle City, New Jersey. It's just like this place that, we go on vacation every year. Why not? Why not? A couple people out there, maybe some folk kids or, some of the other people watching today, they might know what I'm talking about here in Sea Isle City. All right, so again, I'm just testing some new stuff out. Hopefully this green screen thing is working. All right. Yeah, I know the green screen's a little glitchy. You got to remember here, I'm not working with, the world's most high-tech equipment. I don't have a whole studio. In fact, I don't really have much of a studio. I'm sitting in my guest bedroom. If you guys could see what the camera looks like the other way, you'd understand why my studio is not so professional. All right. All right. Dewan, your birthday was yesterday, man. Well, happy birthday. Awesome. Yeah, today's boring, Jared. I get it. Taj wants a shout out. All right. All right. Looks like, who else wants a shout out? That looks like Caleb wants a shout out. All right. Here we go. All right, so today's lesson, I guess it's not lesson, it's more like fun. Today's fun is going to be about a couple different things. I'm going to answer a couple questions from yesterday, not all of them, but I'm going to answer a couple things from yesterday. Today we're going to talk about the bananas being radioactive. I believe that was you, Caleb, that wanted that. Why volcanoes go dormant. That was Torin, I believe, from earlier on in the week. And we're going to talk about, Sua had a question yesterday about life on Earth and how long it's been here and how did it get here. I'm going to do a variation of that question today, Sue. I'm not going to answer the whole thing because it's a rather lengthy explanation, but I'm going to tell you a little bit about life on Earth and past, present, and what's going on with life right now. And then a little bit about Newton's laws for those of you doing the egg drop to give you some ideas about the egg drop. All right. Yeah, we are, Sophia. We're definitely learning about why bananas are radioactive. In fact, I'm going to start with that one. So let me get to my stream here. I'm actually going to make my face smaller so that you all don't have to stare at my face this big on your screen. I know you don't really want to. There goes the picture of Sea Isle down from behind me. And let me move this down. That's me. Get myself out of there. I'll put myself in the bottom corner today. All right. That's pretty cool. All right, that'll work, I believe. And let me get rid of that little picture behind me. All right, cool. All right, so now let's talk about why bananas are radioactive. They are slightly radioactive, just a little teeny tiny bit. Let me pull up a picture here for you as soon as I can find it. It's right here. All right, bananas are slightly radioactive, okay? It says right here, eating a banana exposes you to about 0.1 or 1/10 of a microsievert of radiation. And there's even a name for that. It's called BED, the banana equivalent dose. All right? And this is for real stuff too. There is radioactive stuff in a banana, but it's so small that you would have to eat about 400 bananas a day for your entire life to have some sort of radioactive poisoning. 400 bananas a day. All right. Now you measure radiation in what's called a sievert. Okay. There's microsieverts, there's millisieverts, and then there's sieverts. This is zero point 0.1 microsieverts in one banana. You need 1,000 microsieverts, 1,000 full microsieverts to make a millisievert. And then you need 1,000 millisieverts to make one sievert. So let's see what that looks like. If you look on here, if you've ever had a CAT scan before, the doctor, the organ that's being studied in your body receives total radiation of about 15 millisieverts. Okay? So that's almost 10,000 times more than one banana. Okay? If you ever get an x-ray at the dentist, all right, that's 2/100ths of a millisievert. All right? And it says right here, exposure to 100 millisieverts a year in the lowest level at which you can any increase in cancer risk. All right. So those of you worried about eating bananas and getting cancer, not going to happen. All right. So there you go. Bananas are, in fact, slightly radioactive. And the reason why they're radioactive is because in a banana, it has potassium. And potassium can decay with radioactivity. So that's why bananas are radioactive. All right. So I believe that answers your question there, Mr. Caleb. All right. So about bananas being radioactive. Let me see what's going on here with any questions that we may be having. Clayton's typing a bunch of random stuff, I see. All right. What's up with that? Are we still on the fact that it's Alana's birthday and we're still saying that nobody asked her? It's Alana's birthday. She's allowed to ask us to tell people it's her birthday. No worries. All right. So now let's go to my next topic. And my next topic on here is why volcanoes go dormant. Now, before I do anything else, I want to talk to you about different types of volcanoes. All right, let me tell you about different types of volcanoes. All volcanoes are not the same. Okay, all mountains are not volcanoes, and all volcanoes are mountains. All right, so a volcano is a mountain, but what makes it a volcano is that underneath the volcano, in the earth, down in and under the crust, is what is called the magma chamber of a volcano. So a volcano has underneath it a magma chamber. This is where all the magma stays in the volcano. Okay. Now, some of you are going to say, well, what about lava? Well, magma is when it's underground, and as soon as it comes out of the volcano, then it's called lava. Okay. I'm going to refer to magma because we're going to talk about stuff under the ground today. Now, this down here is called the magma chamber. And it fills with magma from the mantle of the earth, which is one of the layers of the earth. And we'll get into all that kind of stuff when we get back to school, okay? But here's what happens. Why does a volcano erupt? Well, a volcano erupts because in the vent, which is this tube that goes all the way down through the center of the volcano right here, that becomes filled with solid magma when it's not erupting. It's hardened rock, all right? Magma is just melted rock. So when it solidifies, it turns into a solid rock. So what happens is this is totally clogged up with stuff, with solid rock. Well, down here in the magma chamber, magma has gases in it, okay? And it has bubbles. Those bubbles start building up pressure inside the magma chamber. It's just like if you take a bottle of soda and shake it up. You shake up the bottle of soda and take off the top, what's going to happen? Soda comes flying out. Well, the rock inside the volcano acts like the top on your bottle of soda. When that pressure builds up inside that magma chamber, eventually, if it's strong enough, it's going to take the rock that's solid in this vent right here, and it's going to literally blow it out the top of the volcano. And we're going to get an eruption. All that stuff's going to come out right out of the volcano. Forms an eruption cloud, all right? And then it'll stop erupting when the pressure in there is low enough that it can't force the magma out anymore. Well, what happens when it erupts again? Well, the magma chamber has to gather more magma. It fills up with magma again from the mantle, builds up that pressure, and erupts. Now, a volcano becomes dormant when that magma chamber refills extremely, extremely slowly. All right, it can take a year. It could take 10 years. It could take 100 years. Mount St. Helens in the United States was dormant for almost 200 years. People thought it would never erupt again. If it never erupts again, then it's called extinct. Okay? Magma needs to fill the magma chamber. And while a volcano is dormant, it's just not getting that magma into the chamber that it needs to fill up. All right? Once it goes back in there, and all of a sudden it's going to start building up that pressure again. And there are some warning signs for eruptions, and we'll talk about those a little bit later on in the school year. But Torrin's question was, why does it go dormant? A volcano goes dormant when Your magma chamber runs out of magma, and it's a slow process to fill it back up and build up that pressure for a volcanic eruption. All right, so that right there is why it goes dormant. Now, give me a little idea here, guys. How are we doing on the stream? Are things looking better? Are things looking better? I'm glad we're talking about bananas. All right. It's kind of funny how things are starting to shake out here in this group chat. You know, people are talking, people are chatting. Great. Broccoli's the best vegetable. I agree, especially if you roast it. That's what you got to do to it. All right. Nalani is putting Barney lyrics in our chat. Awesome. Okay. Now, let me go to my third topic of the day. And my third topic of the day is going to be about life. Life on Earth. Okay? Now, this is kind of geared towards Suha. Suha asked me yesterday how life began on Earth. And, how did people get here? All right? That's a big question. That's a hot topic question. And there's a lot of science behind that. There's a lot of religion behind that, and I kind of mentioned that kind of stuff yesterday. But here's what I want to do. I want to take, if you could put the entire universe on a calendar, 1 year calendar. Here's the kind of way that things would kind of shake out. All right, we know a calendar goes from January 1st all the way to December 31st. That's a full year. So on New Year's Day, all right, boom, we would have had the Big Bang Theory. And the universe is created, all right, on New Year's Day. That would be the first day of the universe. Now, 2 months later, in March, the Milky Way forms. That's the galaxy that we live in, all right? And it took a while for that to form. I mean, look at the calendar here. It took 2 months. But now we go another 1, 2, 3, 4, 5 months all the way to August of our cosmic calendar until the sun was formed. The center of our own solar system, okay? The center of our own solar system, which is about 4.5 billion years ago. Now, if you took that on a calendar and moved it to September, this is when the first known life starts to appear, 3.5 billion years ago. Life not like we know it right now. Microscopic, okay? You couldn't see it, all right? It was not intelligent life, all right? Microscopic. October, 2.3 billion years ago. Now, all of a sudden, we get some oxygen in our atmosphere. There's oxygen. And we all know that if you can have oxygen, then you can breathe. So now, when we get into November of that calendar year, now complex life starts to come around. These are coming to be the plants. Okay? Plants, and then life evolved from there. Now, that was 2 billion years ago. Now, in order to understand all the rest of this, you have to break up December into its own days of the month. All right? So here we go. December 14th. Would have been the first animals on Earth. All right, the first animals on Earth. 670 million years ago, those animals would have showed up on Earth here. Okay? December 17th, we get the first fish in the water. 530 million years ago. All right? Now, December 20th would be land plants. Those other plants before were underwater. They were aquatic plants. 490 million years ago, life started in the water, and it moved onto land from there. On December 21st, it would be insects, 400 million years ago. Crazy part about that is we had a lot more oxygen in our atmosphere back then. So those insects were not smaller insects like they are now. Insects were way bigger because of the amount of oxygen we had in our atmosphere. About 370 million years ago, which would have been December 22nd, we have amphibians. All right. And then the 23rd, shortly after that, about 70 million years later, which is about a day in December, we get reptiles. All right. December 25th, Christmas Day, 230 million years ago, dinosaurs would have been around. And mammals. We're mammals. Doesn't say humans. It says mammals. All right. On December 26th of our cosmic calendar, about 200 million years ago, the 27th would have been birds, about 150 million years ago. Flowers. Now we have flowers on plants, about 130 million years ago. On the 29th, nothing. On the 30th is when the dinosaurs went extinct, about 65 million years ago. Now here's the crazy part. Now if you break the last day of our cosmic year up into hours on the clock, at 6:12 a.m., the first apes appear on Earth, about 28 million years ago. At 9:11 p.m., humans and chimps diverge. So now all of a sudden we have humans and chimps. 6 million years ago, At 11:52 p.m., 8 minutes before midnight, the modern humans, us, anatomically modern humans, about 200,000 years ago. And at 11:59 and 49 seconds, the Great Pyramids were built. And 1 second before midnight, if this were a calendar of the universe, 1 second before midnight, Columbus would have traveled here to America. Okay? So that's crazy. Think about that. In all of the time of the universe, in all of the cosmic time of the universe, if it were an entire year on a calendar, humans would have been around for 8 seconds of a whole year. In the last 8 seconds of a year is when humans would have showed up here on Earth. Mind-boggling if you think about it. All right? So there's my second question for the day. All right. Just checking out the chat here. Seeing what's going on. All right. Sometimes I think I'll have hot sauce or ketchup. Yeah, it kind of looks like that. You guys are funny. All right. Finally, last thing for the day. I want to talk a little bit about the egg drop. I'm getting a couple submissions of the egg drop. I know there's people out there working on the egg drop. It's kind of turned into a little competition here between some of us, which is great. All right. So here's what we're going to do. Can we turn in assignments if we are in Group A? Sue, I just still need to know what you mean by Group A. And I think that means in Mrs. O'Neill's class. There is a way. I can talk to Mrs. O'Neill. I'm not sure what she's going to say about that. I will let you know. I will let you know about that, though. So here we go. The last topic of the day is about the egg drop. I want you to realize something about our egg drop. All right. There is a little law of science about a man named Newton, Sir Isaac Newton. He's the one that was sitting under the tree and the apple fell on his head. Well, he came up with and proved 3 laws of motion in our universe. They are 100% true all the time. A law is 100% true, proven true all the time. He came up with 3 laws of motion, and this is for any piece of matter that has mass in our entire universe. Law number 1, an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an outside force. So here's what that means. If I take my phone and I put it on my hand right here, it will literally stay on my hand forever until there's an outside force that moves it. That outside force can be gravity. You know, if my arm starts to get tired because gravity's pulling it down, well, my phone's going to go with it. That outside force can be a force from outside, like my hand. If I hit my phone, it's going to fly that way. Okay? That also means that if something is moving, let's say my phone is sliding across the table, it's going to continue to move in the same straight line forever until there's a force to slow it down or stop it. And in the case of, my phone, if it's sliding across the table, friction is going to slow it down. All right? Not much to do with the egg drop experiment on that one. Second law of motion is that an object will move as fast as the force that moved it. Not important, really, to the egg drop. And third of all, this is the one that's going to be important for the egg drop if you look at the screen right here. It's called Newton's third law of motion. It's for every action, there's an equal and opposite reaction. Here's what that means. Every time something hits something else or touches something else, the force at which it hit the object, that other object gives the same force back in the opposite direction. Okay? So again, on my screen, if I take a tennis ball and I throw it down on the ground hard, it's going to hit the ground. Not only is it going to send energy into the ground, okay, the ground is going to put an equal and opposite force back up into the tennis ball. And that's why the tennis ball bounces back up in the air. The harder you throw it down, the more force it hits the ground with, the more force it's going to come back up off the ground with. All right? It's the same reason why when you're playing tag with your friends and you're running and you're not paying attention to where you're going and you run into a tree, well, guess what happens to you? You don't hit the tree and stop. You hit the tree, you fall backwards. Equal and opposite reaction. That tree, not only did you put a force on that tree and it stopped you, that tree put a force back on you and you went the other way. If you've ever been on roller skates before and you go against the wall and you push yourself against the wall, you push on the wall, well, the wall pushes on you and you go backwards. Okay? Same reason why when you are getting off of a boat and you push backwards on the boat, you go forward, the boat goes backwards. Equal and opposite reactions. Now, how does that relate to the egg drop experiment? Well, think about this. When you have your contraption there and you have it up, near your ceiling and you drop it, that egg is now falling. And gravity pulls things down in our Earth, in our atmosphere at a speed of 32.2 feet per second. That's pretty fast. Okay? One, if you could figure out a way to slow that object down when it hits the ground, not only is the egg going to go down towards the ground's going to put a force back up on that egg. So not only do you have to worry about the egg coming down, you have to worry about the force of the floor coming back up. The harder the egg falls down, the harder the force going back up. Newton's third law. Think about that. Think about that when you're doing your egg drop experiment. I see this question often, and people ask me this question often. Is water wet? Well, the molecules of water make up the substance of water. So I do not have an answer if water's wet. I don't know. I'm not really sure if water's exactly wet, but water can get other things wet. Water itself is it's a combination, it's a compound, all right, of elements. Hydrogens, oxygen, 2 hydrogen, 1 oxygen, H2O. H2O. Heat isn't hot. Heat is just the motion of molecules in an object, Josh. Remember that? All right. So, if anyone ever jumped up at the same time, what would happen? Ooh. I don't know what would happen, Sophia. I'm going to look that one. That's going to be something I'm going to look up. If everyone jumped at the same time. I'm just making notes for tomorrow. Okay, I'm going to think about that one. Keep them coming, guys. Is water wet? You know what? I'll do some research into that one, too. I've been asked that question enough over the last couple of years. We'll figure it out. All right? Clayton, are you really quoting Eastbound and Down? That's great. The song? Loaded up and trucking. Nice. Is water wet? Is heat hot? No water is a rock. Now you guys are just getting silly with your questions. All right, listen up. Do me a favor. Ask me some questions that you really want to know the answer to. All right? And we'll go from there. Some people have been putting questions in the comment section, which is great. Keep doing that if you need to. All right. Pretty soon I may have to cut the chat off if we can't ask questions that are appropriate to this little stream. Okay. You guys can have conversations. That's great. But there are people here that want to actually learn to talk about the things that I'm talking about. All right. If you want to be here, be here. If great. So I'm going to sign off for the day. You guys can stay here and chat if you want to. Hope the stream was better today. I really do hope the stream was better today. It like I said before, it is hump day. It's Wednesday. I wish I could go outside and do something. I might go out for a little bit. I don't know. Not really sure. Kind of a gloomy day today, but that's all right. That's all right. Stay safe, guys. Have a wonderful night, and I will be back tomorrow. I'm going to try to get myself another hat that I can put on my head to make myself look like,